Before we begin, let's review some ON24 housekeeping items so that you can participate in today's presentation. On the ON24 console, you'll see a number of boxes that you can move and resize to suit your preference. If you have any technical difficulties during today's session, use the help box at the bottom of your screen or the Q&A box to message us directly. If you have any questions for the presenters, please type them into the Q&A box. We'll answer as many questions as possible at the end of the presentation. Afterward, our presenters can reach out to you directly with any remaining questions. You can download the slide deck for today's presentation from the resource box on your console. You can also find direct contact information for your presenters and me in the Meet Your Speakers box. Feel free to share information from today's session on social media. Please tweet or post about it with the hashtag DWWebinar. Now, I'm happy to introduce our presenters. Ron Hibbler is the manager of Proportion Air's applications team. He has been with the company for 19 years, helping customers choose the right product and providing technical support for complex applications. He works from the Gulf Breeze, Florida location. Hammond Willie is a specialist for the Berlin valve line. His experience with Berlin predates Proportion Air's acquisition of the brand, going back 11 years. He is at the Groves, Texas location, east of Houston. James Spence is a business development manager who has also spent time in the company's applications area and on the production floor. He's been with the company for 4 years. When he's not on the road with customers or distributor partners, you'll find James in the Indiana location. We are so grateful to have all three of you here today. Ron, I'll turn the microphone over to you so we can get started.
Thanks, Rachel. If you knew about Proportion Air before this program, you may have known that we're in a wide range of industries. While today we'll be focused on the medical industries, we're seeing growth in aerospace, food, lasers, semiconductors, and rubber and tire manufacturing. What makes medical a great fit for us? The need for accuracy, consistent parts, and customization in medical manufacturing. We look forward to telling you more about it for the next 30 minutes or so. Please feel free to ask questions in the Q&A box. You may remember when you signed up, we promised to cover the objectives on the screen, including why resolution is critical, maintaining accuracy, protecting from overpressure, and high repeatability and flow control. I'm going to hand the stage over to James, one of our talented business development managers, to discuss some common pressure applications.
Thanks, Ron, and welcome everybody. Okay, we're going to approach these applications from a how and why it works standpoint, but we know everyone's needs are unique. So what if you need 2 to 136.5 PSI? We can do that. Custom pressure ranges are our specialty. It's not just about 100 PSI units. We also offer options for materials, command and monitor signals, and many different connector types. Okay, on to the good stuff. The first application we'll talk about is leak testing. Leak testing is a very popular application for our products. It's a requirement in many industries and can be undertaken in many ways. Whether you're using pressure decay method, vacuum decay, cracking pressure testing, testing in a chamber, burst testing, or simply a bubble test, accurate pressure control will improve your results. One of several leak test examples we have in the medical manufacturing environment is leak testing IV bags. This same principle can apply to any leak test where the item needs to be filled and then fully exhausted of the fluid. In this example, we use a QB3 pressure regulator to test an IV bag for leaks. The QB3 is an ideal choice for the application because it negates the need to use 2 separate devices. With many manufacturers, you'd need a device for positive pressure and one for vacuum. The QB3 handles that all in one unit. Let's see how this works.
Quality control is imperative in medical equipment manufacturing. Producing IV bags is no exception, so they are tested before they go into use. In this example, we use a pressure regulator to assist testing an IV bag for leaks. First, a signal is sent to the QB3 to command the amount of pressure to be applied to the bags. The regulator applies positive pressure to fill the bag with the test gas. The bag is isolated by a small valve. Once isolated, pressure is monitored for a period of time to verify that no leaks exist. Once the test is complete, the QB3 is commanded to apply vacuum and the gas is voided. The bag is now ready to be filled with the required fluid. This process provides a safe, effective experience for the patient.
Okay, so just like we saw, filling the bag to an accurate pressure and evacuating to an accuracy flow is important. We offer accuracy as high as plus or minus 0.2% of full scale, repeatability of plus or minus 0.02% of full scale calibration, and a resolution as high as plus or minus 0.005% of full scale calibration. A separate pressure sensor is not required to verify pressure when using a proportionaire electronic pressure controller. For applications with extremely tight tolerances, our high resolution proportional regulators, which we will get to later, they're a great choice. Pressure is held at the necessary level, and the leakage at that pressure is then actively measured by a flow transducer. The smooth, steady control of the proportional solenoid results in an error-free flow transducer output. While the pressure requirements for the prior leak testing application were under 175 psi, which is within range for several of our products, the QB3 is selected because of the higher flow requirements. This product and its big brother, the QB4, have integrated volume boosters to handle flows up to 200 SCFM. This offers a smaller footprint than an assembly, performing the same work. We also have units that can handle extremely low pressures, like 0 to 2 inches of water column, or pressures as high as 5,000 psi and greater. As we mentioned in the leak testing application, a single unit can handle vacuum through positive pressures. Nearly all of our electronic units have this capability. Now we have a little poll so that we can get to know you better. How long is your usual product development process? And you can see we have various ones you can fill out here. Okay, thank you for those answers. It looks like 1 to 2 years is the most popular. The next application we will cover is injection molding. This application works similarly, whether you're molding glass or plastic. A proportionaire dual loop QBX pilots a high pressure ratio regulator for gas assist in this injection molding application. A DST pressure transducer provides the second loop feedback to the QBX. This ensures tight regulation of the application. Gas pressures up to 7,500 psi follow a partial polymer fill to create hollow channels and cover all the internal surfaces. A polymer is introduced into the mold, and the pressure control assembly forces the polymer into the voids. It then cools into the shape of the mold. The part has stiffness without additional weight. One of our objectives today was to cover how to maintain accurate pressure in a high flow process. We've already explained how our QB3 has an integrated volume booster. The two-loop assembly with an external pressure transducer, like in the injection molding process we just showed, is another great way to accomplish pressure control in high flow processes. In this assembly, the QBX unit pilots a volume booster, which you may know as a pilot-operated regulator or dome-loaded regulator, like pressure reducing or back pressure. The volume booster allows for additional flow to the application. A pressure transducer is added to the assembly to measure the output pressure of the volume booster. This provides a feedback signal to the QB2. The QB2 adjusts the dome pressure based on this feedback to achieve the commanded pressure in the process. Even with a full assembly, we still maintain plus or minus 0.5% accuracy, pardon me. While an assembly may look complicated, they're basically plug and play. You may have noticed that on our prior slides, you didn't see any reference to a PID loop. Ours are truly closed loop devices. No PID loop programming is required. The units come from the factory, calibrated and ready to hook into your system without complicated programming. Another benefit over I2Ps is that our devices aren't prone to drift. If it looks like you're seeing drift, check the system for plumbing leaks, wiring, and electronic signal levels. Always verify the accuracy of your measuring equipment before recalibrating. With our electronic products, it's possible to get a true 0 PSI set point. That little star you see is a reference to our Berlin valve regulators. Those are a Class 6 shutoff with elastomeric seats. Our products are immune to shock and vibration and can be mounted in any position without affecting the outlet pressure. The only exception to this is the QB3, which has to be mounted upright in applications under 10 PSI. Shifting gears just a little bit, our next application is overpressure protection. Overpressure can be a concern when working in sensitive applications. Applications that require precise pressure regulation to fill small volumes benefit from an additional regulator that controls the supply air before it reaches the electro-pneumatic pressure regulator. This is especially true when you're dealing with inches of water column or other small values. Output pressure is easier to control when supply pressure starts closer to the desired output pressure. When there is high pressure differential between supply and output, the inlet valve may not operate fast enough to prevent large set point overshoot and instability. Repeated or sustained large overshoot can lead to sensor damage. A miniature regulator like the Save Air lowers the pressure of air coming into the EPR to a preset limit, protecting that internal sensor from overpressurization and reducing overshoot or instability. Miniature regulators like the Save Air offer many options to reduce pressure in a supply line. Other good candidates for medical manufacturing are the EcoReg and Fluid Reg, which can handle liquids, also the OxyReg, which I will describe next. All of these units are compact, easy to install, tamper-proof, preset or factory calibrated, and inexpensive. For applications using oxygen, the OxyReg is a great product. Its reliability, lightweight, and service-free. No adjustments are needed. Like all of these regulators, it's preset from the factory and tamper-proof. These are made from Grevery, which is an FDA-approved material, and they have stainless steel internal components. The OxyReg reduces oxygen waste, saving energy and money. It's a good fit in applications like anesthetic equipment, food and drink preservation equipment, and nitrogen filling systems. All right, we do have a brief trivia if everyone would get involved. We have this bag. It is actually a proportionaire koozie bag lined, so you can put your cold items in it, hot items, whatever, and a $50 gift card. And our trivia will be, according to the Advanced Medical Technology Association from 1980 to 2017, how many years were added to the US life expectancy thanks to advancements in the medical industry? So the first person that gets this right, we're going to get a hold of you afterwards, and we will get that stuff to you. All right, Ron, I'm going to hand it back to you now. I apologize for the delay. It looks like we have a little problem going on. We'll be right back with you.
Okay. I think I'm back on here. Can you hear me, James?
Yeah, I got you back. We lost you there for a minute, Ron. Go ahead.
All right. Okay. Just the explanation of resolution is the smallest change in command that will result in a change in the output pressure. It can also be described as the ability of the transducer to resolve an output signal into units on a scale of the output device. High resolution means that a finer scale is used, which means the amplitude of the full scale is divided into smaller increments. This is critical when performing work like controlling microfluidic flows. When you have smaller increments to work against, it becomes easier to offer specific and even minute results or work at the cellular level. We achieve this high resolution pressure control through the use of a true proportional solenoid valve coupled to a unique analog PID control circuit. The true proportional valve eliminates digital stepping. A very common use for high resolution products is microfluidic applications, where very small amounts of a gas or a liquid must move through tiny channels. When you use highly accurate and high resolution products, it provides stable and repeatable pressure control, which results in stable and repeatable flow through the microfluidic channel. Our MPV and QPV electronic pressure regulators can be used to precisely control the pressure to a single microfluidic channel or multiple channels. These products offer accuracy of plus or minus 0.2% and a resolution of up to plus or minus 0.005% of full-scale calibration. Again, that stable and repeatable pressure control results in stable and repeatable flow through the channel. Many industrial groups and academic researchers find microfluidics attractive because it greatly reduces the consumption of samples and reagents. Also, the experiment time can be shortened and multiple tests can be run simultaneously. In short, microfluidics provides more actionable results much faster. The need for fast response isn't only for microfluidic applications. Products in our electronic regulator category offer a pneumatic response of less than 1 second and an electronic response in under 10 milliseconds. And it may go without saying, but all of these devices give you the ability to remotely control and monitor your process. The next application we'll cover is differential dispensing, where removing the manual aspect of the process can save a lot of frustration. Many applications require precise pressure control for a process that is relative to a different pressure in that same process. In other words, differential pressure control. In this schematic, 2 proportionary QPVs, one of our high resolution products, are working in tandem to dispense a combination of a sample and a solution in a differential dispensing application. A counting sensor is gathering information at the point of dispensing and sending this information to the PLC, where command signal is calculated and supplied to both QPVs. The QPV controlling pressure over the sample is calibrated 0 to 30 psi. The QPV controlling pressure over the solution is calibrated -1 to +1 psi, with the intention of constantly maintaining a specific differential pressure of solution to sample. The QPVs come standard with an atmospheric reference point. This is the 0 point where pressure is referenced. The solution dispensing QPV has its atmospheric reference point port tied to the output of the sample dispensing QPV. That is shown as the differential sense line. This means that whatever pressure is being controlled by the sample dispensing QPV, the solution dispensing QPV will use this as its baseline for controlling pressure. For example, if the QPV1 controlling the sample is set at 15 psi, the QPV1 controlling the solution would be plus or minus 1 psi or 14 to 16 psi. That controls the amount of solution that goes into the sample. While all of our devices provide superior accuracy and repeatability, our high-resolution series pressure regulators use exclusively proportional valves, which allows even greater precision when making adjustments. These units are perfect for the most critical applications where extreme accuracy and repeatability are a must. We can provide the highest resolution in the pneumatics industry at plus or minus 0.005% of full scale. The SPV is a special product in this line. When your application is to control carrier gases, when there's no need for an exhaust valve to relieve pressure, the SPV is a great choice. It is used in applications where the media is consumed downstream. This compact high-resolution valve does not have the ability to exhaust downstream pressure, only fill and control during constant flow conditions. The SPV trims all unnecessary size and weight while maintaining similar high performance as the larger, more rugged QPV series. Now we're going to have another survey question. How do you seek out application solutions? In this case, you can select all that apply. Okay, well, we'll see what everybody says here. On my screen, everybody says 0, so I guess nobody answered the questions. I know that's not true, but I know James you might have the get the results of that survey.
Ron, yeah. Actually, mine came up a little bit different. So yeah, I don't know. It may be taking a minute. We can get back with them later.
Okay, we'll get back with you later on that. We covered a few applications that highlight our pressure regulating capabilities, but that's not the only process variable we control. Our devices can be used in any pneumatic application to control the pressure, flow, force, tension, or vacuum of the process. Specifically, our products can monitor and adjust pressure ranges dynamically. We can measure and control flow across calibrated venturi, let's say P1 versus P2, or send and receive signals from a load cell to control force. This force control, we can measure tension and compression, and produce and or maintain vacuum and a vacuum through positive pressure range. Our next few applications will feature flow control. In this application, an FQP-V2 proportional valve and an F-series flow monitor accurately control the flow of air in an atomizing spray and medical product coating application. The F-series measures the flow and provides a second loop feedback signal to the FQP-V2 to either increase or decrease the flow. As the pressurized air combines with the coating material, the material is atomized for spraying. It coats consistently and accurately. In this atomizing spray flow control application, the mass flow controller will automatically compensate for any buildup in the nozzle. As the nozzle clogs, the pressure is increased to maintain the plume. This increase can easily be monitored to know when to clean a nozzle. This prevents irregular coatings and limits downtime. The repeatability of our flow control products is what sets them apart from the competition. Our high repeatability specs mean that each execution is consistent, delivering the same result each time and ensuring quality. Our mass flow series comes in 3 options that mirror our EPRs. Flow measurement happens in under 10 milliseconds. The FQB2 offers 25 to SCFM maximum flow, and the FQP-V2 handles a maximum flow range from 1/3 to 1 SCFM, and the FQB3 covers from 2.5 to 25 SCFM maximum flow. 3 models are available as well. For an application that has a fixed regulated supply pressure, the FR model is the best choice. Hyperbaric chambers, which you'll see, is an example where this is the case. A pressure compensated model works in applications where the inlet pressure varies, like when your air supply is unregulated. Let's say you need to meter out gas for a cylinder speed control application. An FA model is an excellent option. Its output port must be open to atmosphere and to work properly. It is calibrated for the density of gas at atmosphere. Our next application is the hyperbaric chamber. We're going to have an animation that shows FQB3 and F-series closed loop flow controller working together to control the flow of oxygen into the chamber. In this case, we use an FR model since the inlet pressure is ignited and known. I'll let this play and then we'll hear from Ham and Willie.
A hyperbaric chamber is used for oxygen therapy. This aids in the treatment of decompression sickness in divers, traumatic brain injuries, and the healing of wounds. A flow controller and a back pressure regulator maintain the environment. To pressurize the chamber, an electronic signal is sent to the flow controller and the electro-pneumatic back pressure regulator assembly. The flow controller allows oxygen to enter the chamber at a specified rate. The F-series flow monitor measures the flow rate and provides feedback to the FQB3. The FQB3 will then adjust as needed to maintain the specified flow rate. pressure in the chamber begins to rise and will continue until the set point is reached. Once the set point is reached, the back pressure regulator will open and allow oxygen to flow out of the chamber. Using feedback from the upstream pressure transducer, the back pressure regulator will maintain specified pressure in the chamber. Once the treatment inside the hyperbaric chamber is completed, the flow controller will exhaust the pressurized oxygen so the patient may exit safely.
Hello, you may have noticed in the last feature that our Burling valve line was in that application. If your medical manufacturing is in a more industrial environment, Burling valve process pressure regulators may be a good fit. These heavy-duty products offer high CV ratings, easy inline maintenance, and fast delivery. Whether your application requires just a mechanical spring-loaded regulator or you have an option for piloting. An application that can also often be successful with a spring-loaded regulator is cryogenic pressure building. Here we're showing how a pressure-reducing differential regulator maintains pressure in a vapor space above liquid and cryogenic vessels, like a Dewar container. The liquid in the lower part of the vessel is vaporized before reaching the regulator's body, which is a set pressure determined by the spring position and the seat placement. The vapor on top of the liquid passes to the chamber by using a light spring with low droop, assisted by the gas pressure. A highly accurate pressure of 275 psig or more is attained. The set point is capable of accuracies of plus or minus 2 psig. Cryogenic fluids aren't the only challenging fluids we work with. We won't name off everything here, but you can see that Burling offers a lot of versatility with media, including inert gases and caustic fluids. These are just a few of the capabilities of our products. If you're already at the stage where you're interested in a quote, we just need some more information. Let us know your pressure and flow range, your preferred unit of measure, and the media. And that will get our team well on the way to helping you. Application specialists use your submitted information to determine a product that best fits your needs. They may reach out to gather additional information. This is where customization may be needed in order to adapt to a specific part. Our goal is to have your quote delivered within 6 hours of completely understanding your needs. Now, our final question for you. What are your favorite ways to communicate with a company? Again, it looks like we're having some issues with the poll results, but we will get back to that with everyone. Thanks. You'll see on the On24 platform that we have several documents available to download, including our catalogs and white papers. We invite you to check those out. If you'd like to know even more or speak with James, Ron, myself, or one of our other experienced application specialists, please drop an email to info@proportionair.com, or you can call the number that's listed. Support is free and you'll speak to a live person. Be sure to learn more about us by visiting our brand's websites, where you'll find applications examples and information on our parts. We're soon to release an updated website that includes all 3 brands in one place. Also, you can keep up with us by following Proportion Air on social media platforms like Facebook, LinkedIn, and YouTube.
All right. Thank you, Ron, Hammond, and James for such an informative presentation. It's now time to answer questions, so please submit them to the Q&A. Looks like we have a few already. First question, we saw the fluids that Burling Valve can handle. what fluids are compatible with proportion air products?
Thanks for the question, Rachel. So, with the exception of a few outliers, it's primarily air and inert gases. We do have the FCV, which can handle liquids. Any other thing, I'd just feel free to contact us. We will definitely work with you to try to figure out a solution. Thank you.
Next question is, what are your lead times?
Okay, Rachel.
Standard lead times, I'm sorry, go ahead.
Yeah. Yep, our lead times will vary a little bit. We build all of our products to order. So that normally it's going to start at about 3 weeks for our lead time for our built products. And we always will get you a quote, which will outline the actual lead times for the products that you're ordering.
Okay. Looks like we have one more question. We've heard both valve and regulator today. Are they the same thing?
Well, a regulator is a valve, but not all valves are regulators, if that makes sense.
Okay, I think that does it for questions. So if you have any other questions, please feel free to continue to submit them to the Q&A, and you can be contacted directly. Thank you everyone for attending this Design World webinar, and thank you so much to Ron, Hammond, James, and Proportion Air for helping bring this great information to our audience. This presentation will be emailed to everyone later today, and it'll also be available at designworldonline.com. Thanks again, everyone, and make it a great day.
Thank you, Rachel.